Today's lesson will be focusing on parallel and perpendicular lines. By the end of today, you're going to be able to identify properties of both parallel and perpendicular lines, tell whether or not they are parallel, perpendicular, or neither, and write the equations of lines that are either parallel or perpendicular. The first thing we're going to do today with parallel and perpendicular lines is look at a graphing calculator activity to help us understand exactly what it means. In the picture on your screen, what you're going to notice is we have a red line and a blue line. The equation of the red line is 2x plus 1. The equation of the blue line is a more generic mx plus 3. So we've got a y-intercept of 3, but an m value that we're going to play around with. We're going to play around with that value down here in this box with this slider. Currently, my m, or my slope, is set to 0 for the blue line. You'll notice the angle between the red line and the blue line is 117 degrees. The first thing I'm going to do is try to make the blue line and the red line parallel to one another. I'm going to do this by sliding the slider down here back and forth until I notice that those lines will never touch. I'm moving to the negatives first to see if I find a pattern, and you'll notice I keep getting further and further negative, and they don't seem to be getting any more parallel. So let's go the opposite direction. If I go the opposite direction, let's get back to 0. Let's see what happens. Alright, I'm heading to the right. Still not parallel. Getting closer, my angle is getting smaller. Almost there. Until finally you'll notice there's no angle between the lines. There's no angle between the lines because these two lines never intersect. Therefore, they never form an angle, which means that the blue line and the red line are parallel. The slope of this blue line right now is m equal to 2. Notice that the blue line slope is 2 as well as the red line slope is 2. Parallel lines always have the same slope. Now let's try to get the blue and red line to be perpendicular. An important property of perpendicular lines is that they form a 90-degree angle. So our goal is to figure out when is this angle going to be 90 degrees. So let's play around with our slider again. I'm moving more positive, and I seem to be moving closer and closer, but not in a 90-degree angle. So let's move the other direction. I'll get back to my starting point of 0 and move left. I've hit a 90-degree angle. I have my 90-degree angle when the blue line has a slope of negative 0.5. Remember, negative 0.5 is the same thing as negative 1/2. In order for lines to be perpendicular, one line has to have a positive slope, such as the red line, who is positive 2, and the other has to have a negative slope. The blue line, in this case, has a negative slope of negative 1/2. In addition of having opposite signs, they also need to be reciprocals of one another. Notice that the slope of the red line is 2/1, while the slope of the blue line we created has a slope of negative 1/2. 2/1 and 1/2. Opposite reciprocals. Write down the properties below. Now is a good time to hit your pause button and record the following. Remember, parallel lines never touch. They have the same slope, but they must have different y-intercepts. Perpendicular lines form a 90-degree angle, which means that their slopes are opposite reciprocals. Let's go ahead and we're going to tell whether the lines are parallel, perpendicular, or neither. But first, let's take a look at our prerequisite knowledge. For some of these examples, you're going to have to remember the slope formula. Remember, the slope formula is given by m equals y2 minus y1 all over x2 minus x1. In example 1, we're given two lines that are in slope-intercept form. Line 1 is the equation y equals 2/3 x plus 10. Line 2 is the equation y equals negative 3/2 x minus 8. We need to determine if these are parallel, meaning they have the same slope, perpendicular, meaning they have opposite reciprocal slopes, or neither. Because these are both in slope-intercept form, it's very nice to identify the slope. The slope of line 1 is 2/3. The slope of line 2 is negative 3/2. Are these two lines parallel? No. They are not parallel because they are not identical slopes. Are they perpendicular? In order to be perpendicular, the two slopes must be opposite reciprocals. Opposite meaning one of the slopes is positive and the other is negative. Well, line 1 has a positive slope and line 2 has a negative, so we're in good shape so far. Are they reciprocals, meaning the flip of each other? Is 2 over 3 and 3 over 2 the flip of each other? Yes, which means these two lines are perpendicular. Example 2 has line 1 with the standard form equation 2x plus 6y equals 24. Line 2 has an equation of the form 6y equals 2x minus 12. In order to tell whether lines are parallel, perpendicular, or neither, we're going to get both of these equations into slope-intercept form. Which means for line 1, I need to get y by itself. To do that, I subtract 2x from both sides of the equation. After doing that, I get 6y equal to negative 2x plus 24. Y still isn't by itself, so I divide both sides by 6, and I get y equal to negative 1/3 x plus 4, the slope of which is negative 1/3. Line 2 is almost in slope-intercept form, but we need to eliminate the 6, so I divide both sides by 6, and I end up with y equal to 1/3 x minus 2, the slope of which is 1/3. Are these two lines parallel? Do they have identical slopes? They almost do, however, one has a positive slope and the other has a negative slope. Are they perpendicular? Meaning, are they opposite reciprocals? Opposite, yes. This has a negative slope and this is a positive. However, are they reciprocals of each other? No. They both have 1 over 3, which means because they are neither parallel or perpendicular, they are neither. Example 3 gives us 2 points for each of our lines. Line 1 goes through -2, -2, and 4, 1, while line 2 goes through -3, -3, and 1, 5. We need to look at the slopes to determine if these lines are parallel. So in this case, I'm going to use the slope formula. y2 minus y1 all over x2 minus x1. So I get y minus -2 over 4 minus -2, which simplifies to 3 over 6, or a slope of 1/2. For line 2 using the slope formula, I get 5 minus -3 all over 1 minus -3, which turns out to be 8 over 4, or positive 2. These lines are not parallel because 1/2 and 2 are not the same number. Are they perpendicular? Well, we have a slope of a positive 1/2 and a positive 2. Because these are not opposites, they are not perpendicular. Therefore, once again, these two lines are neither. You try the following example. Tell whether the lines that go through 6, 2, and 6, 8, and the line that goes through 1, 4, and -1, 4 are parallel, perpendicular, or neither. Hit the pause key and come back to reveal the answer. After determining the slope of line 1 to be undefined, which means it's a vertical line, and the slope of line 2 to be 0, which means it's a horizontal line, these two lines must be perpendicular. Not because their slopes are opposite reciprocals, but rather horizontal and vertical lines always form perpendiculars. Now that we know properties of parallel and perpendicular lines, we're going to write their equations. First, let's look at some prerequisite knowledge that will help us. Hopefully you will remember something called point-slope form. Point-slope form is an alternative to slope-intercept form. It's convenient whenever you're given a point and a slope. It has the form y minus y1 equals m times the quantity x minus x1. Remember, you don't have to use point-slope form, but I'm going to show it using this way. If you'd like to do slope-intercept form, go ahead, try it, we can check it in class. Whenever you write the equations of lines for us, we want you to put the answer in slope-intercept form. Keep that in mind throughout this. So, example 1 asks us to write the equation of a line that passes through 6, 3 and is parallel to the equation y equals 2/3 x plus 9. Let's think about what they gave us in this example. They gave us a point of 6, 3. They also gave us the fact that we want our line to be parallel to the line y equals 2/3 x plus 9. Remember, parallel lines have the same slope. So, because the slope of this line here is 2/3, the slope of our line also needs to be 2/3. So we're going to incorporate that into point-slope form. I have my point, I have my slope. Plug it in. Y minus 3 equals my m of 2/3 times x minus 6. Get it in slope-intercept form by getting y by itself. Distribute the 2/3. I get y minus 3 equals 2/3 x minus 2 times 6 is 12, divided by 3 makes 4. Lastly, add 3 to both sides of your equation to get your final solution of y equals 2/3 x minus 1. Example 2 is also asking us to write the equation of a line, but they're providing us slightly different information to begin with. They want us to write the equation of a line that passes through 8, -2, but in this instance is perpendicular to the line 5x plus 10y equals 40. Two things are different in this example. First of all, we want our line to be perpendicular. Remember, perpendicular lines have opposite reciprocal slopes. Secondly, they gave the equation of the line in standard form. It doesn't help us because it doesn't provide us with our slope. So, the first thing I need to do is put this equation in slope-intercept form. I do that by getting y by itself. I subtract 5x from both sides of the equation and get 10y equals -5x plus 40. Divide both sides of your equation by 10 to get the equation as y equals -1/2 x plus 4. The slope of that line is currently -1/2. Remember, we want our slope to be perpendicular to that. Because I want it perpendicular to -1/2, I want the opposite reciprocal. The opposite of a negative is a positive. The reciprocal of 1/2 is 2/1, which is just simply 2. So the slope we're going to use is +2, not -1/2. The reason being, we want a perpendicular line. So we have our point, we have our slope, plug it into point-slope form. When I do that, I get y minus -2 equals 2, my slope, times x minus 8. Simplifying, y plus 2 equals 2x minus 16, which means y is equal to 2x minus 18. Final answer. Example 3, once again, be careful in the wording. We're writing the equation of a line that passes through -2, 0 and is parallel, once again, to the line that passes through the points -1, 5 and -4, -2. So let's find our slope to help us out here. To find our slope, we have to know the slope of the first line, which connects the points -1, -5 and -4, -2. So let's use the slope formula. y2 minus y1 all over x2 minus x1. Or in other words, I get +3 over -3, which means the line has a slope of -1. Because we want our line parallel, I want that same slope. I've got my slope, I've got my point, we're going to put it into point-slope form. Y minus 0 is equal to my slope of -1 times the quantity x minus -2. Y minus 0 makes y equal to -1 times the quantity x plus 2, and when I distribute, my final answer is -x minus 2. You try a problem on your own now. Write the equation of a line that passes through 4, -4, and is perpendicular to the line that passes through 4, 1 and negative 2, negative 7. Hit your pause button. The solution is y equals negative 3/4 x minus 1. Alright, let's wrap things up here. First of all, when you need to identify if lines are parallel, perpendicular, or neither, the easiest way to do that is by figuring out its slope. That means equations are best identified when they're in slope-intercept form. Remember, parallel lines have the same slope, but they must have different y-intercepts. If they have the same slope and the same y-intercept, they're the same line. Therefore, they touch everywhere, making it not parallel. So parallel lines, same slope, different y-intercepts. Perpendicular lines have opposite, meaning one's positive, one's negative, and reciprocal, meaning the flip, slopes. You must find the slope of a line before you can write the equation of it.